Quantum computing is exciting for everyone in the field, and it's starting to become more and more mainstream now.
If you want to understand quantum computing, you would need to understand the physics behind it first.
Is an entirely new technology, right?
Is not just an elevated form of classical computing, but rather a completely different way of doing things.
Quantum computing, I feel, is a different type of computing, right? It cannot be compared with the classical computing we are already familiar of.
Quantum computing is an emerging technology that is aiming to build powerful processors that will help us to advance on the technology of computation in general, and to help us solve very complex problems that we cannot efficiently solve using the resources that we currently have. How quantum computing works is that we use, or let's say we leverage the most fundamental phenomena of nature in order to do computations and to do communications. And this will even make us understand more of nature, and eventually maybe with quantum computers we'll be able to answer the biggest questions.
It's a different computer which will solve different kinds of problems. The value and the advantage that I see futuristically is in its capability of enabling us to, really deploy not even large, I would say like huge scale infrastructures.
If you want to travel from point A to point B, let's say you need to travel from your house to the nearby grocery store, you can always take your car, bike, or whatever a possible means of travel to do that. Now, quantum is in a way trying to explore areas not explored before. So it's like if you want to journey out in the middle of the sea, your cars won't be doing that just because they aren't able to do that. Quantum computers might be able to solve problems which are just not being solved today. It's not a matter of how quickly or how better they can solve, it's just a matter of they can solve and classical computers cannot solve.
Quantum computing could be complex, and it could be intimidating to a lot of people, even professionals. We do not just learn about manipulating a technology, but it also helps you to understand more of nature and how our world works.
Some specific technologies that I'm actually super excited about are neutral atom quantum computers, computers that effectively use super strong lasers to trap atoms in like a two-dimensional or three-dimensional trap, and then shine other lasers on them to evolve them in time.
One of the more native applications for quantum computing is drug discovery. We're trying to simulate these molecules. Why not try to do it on a more native machine? It was a question by Professor Richard Feynman, and that's precisely what quantum computers offer. The type of molecules and the atoms that you're trying to simulate have particular properties that make them extremely difficult to simulate on a classical computer. But if you have something that looks similar to those molecules that you're trying to simulate, the calculation and the computation suddenly becomes much more efficient.
At QBraid, we're actually trying to apply quantum computing to understand how proteins and metals interact in very, very specific ways. And specifically, the proteins that we're looking at are actually relevant to Alzheimer's disease and Parkinson's disease. So if you can actually develop tools that could address these things in ways that classical computers cannot, that would be absolutely groundbreaking, right, for drug discovery.
Rather than having to go into a lab and experiment with options that have taken a week or a month to synthesize, why not merely simulate it on a computer that can actually handle it? One of the things that quantum processors can do is precisely that.
We believe, amongst others, also that the next sort of exciting area in technology will be quantum computing. The big advancement 2 years ago was quantum supremacy, where Xanadu and others showed that for an esoteric math problem, you can actually go from millions of years to a couple of minutes. Quantum computers are very tricky hardware infrastructures to operate, and one of the reasons is the inability to actually correct errors that occur as you're computing.
I'm an AI scientist at IBM Research. I work at the intersection of systems and artificial intelligence. Certain numbers are showing that energy consumptions of one data center could exceed the energy consumptions of an entire country. So this is really not sustainable. And that's why we have to really rethink How do we solve this problem? The energy, the carbon footprint, the emission. Quantum provides also this potential of solving some of these unprecedented computational power that you can also get with quantum computing to also help solve some of these sustainability issues around AI. We will be in a world where we need to use both quantum and AI together in a hybrid way so we can solve some of these big challenges in the world.
We're aware of the scarce expertise in the world and the limited resource in terms of computational resource available. Most of the funding and the energy, the time is allocated to commercial application and defense application. And what we want to do is, okay, can we steer a little bit to shift the cursor towards application that will benefit humanity?
Students in computer science know that computer science is a problem-solving field, and it really can impact any field around us.
You got a problem, you can do it much faster. You can't do it with all problems, but there's a subset of very important problems like drug discovery, material design.
Energy sector to pharmaceutical to finance, transportation, logistics.
Artificial intelligence that would really welcome the speed ups of quantum computers.